Okay, in the last session we have seen what an infix expression is and how this infix expression can be converted into postfix and what is the necessity of that conversion. See, infix expression will look like this, wherein you have operands coming either side of the operator. So we have the operator, say a binary operator plus, right? So this binary operator needs two operands. So both the operands will appear on either side of the operator. So if that is the case, then we call that kind of expression as infix, right? The expression what I've shown you now on the screen is an infix expression, wherein the operator is coming in between the operands, right? So the same expression could be converted into postfix. This is infix expression, and the same expression can be converted into postfix and use, such as we're going to have the operator coming post operands, right? So if you have a plus b, if the expression is simply a plus b, then the postfix form of a plus b will be ab plus, and the prefix form of a plus b will be plus ab. So this is postfix and this is prefix. Guys, all of you please listen. I request you to unmute yourself and ask your doubts, because I'm just sharing the entire screen. I'll not be able to see the chat window of the meeting, right? So if at all you have some doubts, you please stop me in between by asking questions, unmuting yourself, right? So if you just keep typing on the chat window, then it is not going to help you. Okay, so this is postfix form of the expression what we have, and that is the simplest expression what I've shown here. To convert this into postfix, I told you a method, like you have to completely parenthesis the expression and map the parenthesis, opening parenthesis to its immediate, map the operators to its immediate closing parenthesis in the case of postfix, and map the operators to its immediate opening parenthesis in the case of prefix conversion, right? I hope you remember those things. Maybe I'll do it again. So for this expression to convert, the expression should evaluate this part of the sub expression first, because according to the rule, slash has higher priority than plus. You would have done studied all these things in the very lower classes like 6th to 7th standard. So we apply the Bodmer's rule, where you have this slash operator being assigned a higher priority than this plus. So we have to do the division first and then addition. So the expression should look like this: a b c slash plus in postfix form. Let's see how we get that with the method what I taught you in the previous class. This is again, I'm repeating the same stuff what I did in the previous class. Okay, so we have to fully parenthesis expression considering the priority of the operators. So here this operator has the higher priority among through operators what we have here. So we just parenthesize this part of the expression first and then plus. Now the next step is to map the operators to its immediate closing bracket. So here this operator will get mapped to this closing bracket and this plus here. Rewriting the expression, we have the expression as, when we rewrite the expression, we saw that we're going to just drop all the opening brackets and have all the operands written, write or take these operators to the place where it is to which particular opening closing bracket it is mapped to. So here we're going to have a, then plus is going to move to some other place, and this is opening bracket, so I just drop it. Then we have b, so I just wrote it down here, and the slash again is taking a new position, so we do not bother now. Proceed with reading the next character. So we read C, which is an operand, so we just note it down in the resultant expression. And now we read a closing bracket. This closing bracket has to be replaced with a slash, so we just put a slash over here, that is take the slash here to the place of this closing bracket, and this closing bracket is going to get replaced with plus. So you could see that this is the expression what we get and what is intended to get. So this is the manual conversion of the expression. What is the disturbance there in the class? Yarka, doubt irka? Imtiaz Ahmed. Okay, so here this is the postfix form of it. So to convert the same into prefix, So what we have to do is, the first step is the same, just fully parenthesize the expression and just replace this, or replace all the opening brackets and drop all the closing brackets. Replace the opening brackets with the immediate operator. The operators are going to get mapped with the immediate opening brackets. So here the immediate opening bracket to the slash is this one, and here for this plus it is this. So now the expression, when you rewrite, you're going to have plus coming first, and then A, then you have slash, then BC. So this will be the prefix form of A plus B slash C. So in mathematics you'll call it as Polish notation. And this is called as reverse Polish notation. Right? Is this clear? Any doubt in this? So I taught you 3 steps. One is to fully parenthesize expression, and the second step is to map the operators towards either towards immediate opening bracket or toward closing brackets accordingly. So if you want to have the expression to be converted into prefix form, then map all the operators towards immediate opening brackets. If you want to convert the expression to postfix form, then map all the operators towards immediate closing brackets, right? And the third step is to rewrite the expression leaving all the opening or closing brackets, right? And have all the operators and operands in place, right? So if it is prefix, then you're going to replace all the opening brackets with the operators and drop all the closing brackets. If it is postfix, then you're going to drop all the opening brackets and replace the closing brackets with the mapped operators. I hope this is clear. Any doubt in this? Shall we move on to the algorithm now?
Yes, ma'am.
Okay, what's the big problem here? See, we are converting this infix into postfix, right, or prefix form in order to have or get rid of this brackets, right? And in one single scan, the system will be able to evaluate the expression. That is the very idea of having this prefix or postfix conversion, right? So if it is infix, then you have to trace or scan the expression many number of times to get it evaluated completely. But if the expression is too long and if it is too complex in the sense if the operators are overridden by having brackets, right? So here, see, normally if I give this expression as such, then the system knows that this is the higher priority and it has to evaluate this part of the expression first. But the priority can be overridden by having a bracket over here explicitly, right? Wherein this expression says that first add A and B and then divide the resultant value by C, right? So here the priority of the operator is overridden by the help of a bracket or the parenthesis, right? So if an expression is a complex expression which has lot of overlooked priorities, then the number of times the expression has to be scanned for getting completely evaluated is going to be more. So a CPU will just spend a lot of time in scanning one single expression. To avoid this only, we are converting this expression, infix expression, what we understand easily, into postfix or prefix, right? So how this postfix or prefix expression is going to help the system to just have a single scan to get the expression evaluated is, like I'll show you how it will do. See, if it is A, B, C slash plus, taking the postfix expression. So number of scanning, as I said, it is going to be only done once. So number of scanning will be only 1. So how? It will just start scanning here, and once it encounters an operator, the system will immediately stop and it will just take the preceding 2 operators and apply the operators here and have the result remembered. And it has A and the result of B by C. Now proceed scanning from the next point onwards. It is not going to start scanning again from the beginning. It will just continue scanning here. So when it continues scanning, it reads another operator. So if it reads an operator again, it will stop and take the immediate preceding 2 operands. So here we have A and B slash C. So it applies this operator plus on A and B slash C. Now it gets the result. So it will just put the result back here, which is nothing but A plus B slash C. Okay. Now it will again continue reading here. If it continues reading here, it will just go to the end of the expression, so it will stop. Now you could see that the result has been got just with single scan of the expression. But in the normal case, if you have an expression as such, like if the expression is of infix form, then what it will do is it will just go scan the entire expression and try to identify the operators. So here the operators that it reads are plus and slash, and now it understands that the slash has to be evaluated first. So it will just apply the slash, right, and have the result remembered. And now again start scanning. Now it has got only one operator left here, so it will apply it. So with the two different operators here, the number of scannings what we made were 2, right? If there are more number of operators, if the expression is very complex and lengthier, then the number of times the expression is going to get scanned will also be more. So this can be avoided by having the expression in the form of postfix and prefix. And one thing what you have to keenly watch here is this postfix or prefix form do not have any brackets or parenthesis in it. Clear? Okay, now let me just help you understand how this could be done. The method what I taught you actually demands the user to scan the expression many number of times in order to parenthesize it. So unless until you put the parenthesis properly, you will not be able to get the postfix or prefix form right correctly. So here what we do is, like, we try to scan it completely every time and try to identify the precedence of the operators and then parenthesize the expression. But without doing that, the system has to do it. Well, because the very idea of just scanning the expression many times again is still there. So we have to overcome that. That's the very idea of the whole process, right? But then if you want to just fully parenthesize expression, you need to scan it many number of times, right? But then how to overcome this? So we are going to make use of stacks. We are going to make use of stacks in order to overcome the multiple scans of the expression to get it evaluated. Let's see how that could be done. Maybe I'll take some expression and help you understand it. Okay, let's take this expression, right, and see how the algorithm will work on this expression to get it converted into postfix. So I'll now teach the conversion of infix to postfix algorithm using stacks. So this is the one major application of stack, and all these things are being done internally whenever we use this expression in our program, right? We are not going to write any program explicitly to convert the expression into postfix or prefix so that the system will speed up working on our algorithm. We are not going to do that. It is going to be done implicitly by the system whenever it reads an expression in your program, right? So here the method is very simple. I'll just tell you the procedure first and explain how this procedure works on this example. So first is we have four possible cases. We read character by character from the expression, right? So to convert the expression from infix to postfix, we read every character from the expression. So here, whenever you read, so what are the things that we can read? We have four possible cases. One is we can read an operand. The other possible case is reading an operator. What is the third possible case? You can read a bracket, or we call it as braces, right? Or parenthesis, right? Which is a opening bracket, or the other thing is a closing parenthesis, right? And one extra thing what I can add here is a delimiter, which is going to mark the end of the expression. So this is the delimiter which marks the end of the expression, this one. So this marks the end of the expression. Okay. So only these 5 different characters could be read from any expression. The one what you read can either be an operator or an operand, or it could be a opening or closing parenthesis, or the other possible cases having a delimiter read. So we're going to just see what action has to be taken on reading a particular type of character. So if the character what you read from the expression is an operand, then if it is an operand, say case 1 is reading an operand. If it is operand, just print it. If it is an operator, or I'll just come to the delimiter, simplest case. If the character what you read is a delimiter, then do what? Stop. After reading or popping all items from stack. So if it is an opening bracket, push inside the stack. If the character read as opening bracket, then you're going to push that inside the stack. If it is a closing bracket, pop until opening bracket is read. And the final case is an operator. Reading an operator. You can either read an operand or an operator, or these three things. So if it is an operator, then check for board mouse and push. I'll tell you what this means. So if it is an operator, check the top of the stack. If you have an operator with lesser priority on top, push, else pop. Right? I hope these first 4 points are clear. I'll come to this point later. So try to understand these first 4 points. So when I read an operand, say when I read A or B or C, then I simply print it. Printing in the sense taking that to the resultant expression. Right? If I read a delimiter, which marks the end of the expression, then I simply stop after emptying the stack. If I read an opening bracket, I'll simply push that inside the stack. Right? And if I read a closing bracket, I'll pop items from the stack till I read an opening bracket. So I am trying to match the opening and closing bracket in that case. That is what we are trying to do. Whenever I encounter this opening bracket, I will simply push that inside stack. Whenever I read closing bracket, then I will try to pop out all elements. I try to evaluate this part of the expression, and this part of the expression, beginning of this part of the expression is denoted by this opening bracket. So I keep popping out elements till I read opening bracket. That is what has been mentioned here. And when you read an operator, so operator has to be handled differently. So we are going to use a stack called as an operator stack. This is a normal stack which is named as operator stack. That's it. Nothing new there. So you're going to define a stack which is going to have operators pushed inside the stack. Only operators pushed inside the stack. That is why the name operator stack here. Right? So here, this stack initially will have a dollar symbol which denotes the bottom of the stack, right? So either you can have this or you can have top equal to -1. So this is a stack which is implemented using array, right? This is an array wherein we are going to define this particular single dimension array as a stack, and we're going to use the index top. This top is going to always point to the topmost element of the stack. So when you start with the top pointer is going to point to dollar symbol, which is going to mark the bottom of the stack. Dollar to mark the bottom of the stack. Now what you do is you read the characters straight from here. So let us start working on it. I'll explain you what exactly this means when you're working with the example. So here, let's start reading. So you read A. You read A. What is A? A is an operand. So here, let us say postfix expression. So when you read, this is the resultant postfix expression. Okay. When you read an operand, what is the case here? You have to simply print. Take it to the result. It is A. என் ஃபோன் பேசிட்டு இருக்காங்க. A. So now you read what? You read star. Continue reading here. You read star. Star is an operator. So if you read an operator, then what are we supposed to do? We are going to push that inside the stack, right? But it cannot be blindly pushed. We have to just check whether this star could be pushed now inside the stack in the prevailing conditions. So when can we just push an operator inside the stack? When we find an element, we find an operator. Always this stack is going to have only operators. When the top of the stack has got an operator whose priority is lesser than the one which is trying to now get into it, then we can push, right? So here this dollar's priority say is -1. You also know the priority of the operators, I hope. So here this cap symbol has the highest priority, and then slash and star and plus and minus. These two have same priority, right? This has the highest priority. Priority levels up like this, right? And the brackets actually override the priorities. So here, when you're coming for the implementation of the conversion of infix to postfix, we assign priority to these operators. So the opening bracket has a special case, the special priority case, where the priority of this opening bracket is highest of all when coming inside the stack, and it is the lowest of all when inside the stack. So we call it as in stack priority. In stack priority of opening bracket is 0. Incoming priority of opening bracket is highest of all the operators that you have. Here we consider only few operators, so I say it is highest, right? So we have lot other operators which we are not considering here. Is this clear?
Yes, ma'am.
Okay. Now, so that these priorities should be known to you. So always an operator can get inside the stack only when the top of the stack has an operator which has priority lower than the one which is trying to get into the stack now. That is, you can have an operator whose value is or whose priority is higher than the one which is on the top. It is like this. Operator's priority is being shown diagrammatically here when it is inside the stack. So stack can add a new item into word, right? When the top of the stack has got an operator whose priority is lesser than the one now which is trying to get into word. Okay, so now I read star, and what do I have here on the top of the stack? It is slash. Say for example the lowest priority is 0 here, right? And the priority of this is 1 and 2, 3. These are the priority values assigned. Okay. So slash, this dollar symbol has got -1. So it is -1. So what I do is I just simply push this star inside. Push this star inside. Okay. Now proceed reading here. Proceed reading here. What you read, it is an operand. So if you read an operand, just print it here. And continue reading. What do you read? It is an exponent symbol whose priority is 3. And what do you have now here in the top of the stack? Top of the stack has got star. And the priority of the one which is trying to come inside the stack now is higher than the priority of the operator that is already there inside the stack, on the top of the stack. So I can very well push this inside the stack. So I increment the top pointer and push cap symbol into the stack. Okay. Now what I do, I continue reading the expression. What I read here, it is opening bracket. So when I read an opening bracket, then I have to, so why I said simply push here is, it is going to have the highest incoming, it is trying to come inside the stack. So the priority is highest of all the operators in that case. That is how it has to be assessed. The priority of this opening bracket when it is trying to get into the stack is the highest of all the operators what the expression has got. Okay, then obviously the priority of the one which is there on the top is going to be lesser than the priority of this opening bracket. So I blindly push that inside the stack now. Push after incrementing top. Hope this is clear. Okay, now continue reading. What you read C. So C is an operand, so you simply type it here. C is an operand, you simply print it and proceed reading here. It is minus. Okay, so now what is the priority of minus here? It is 1. What is the priority of the opening bracket which is there on the top of the stack? It is now 0, because the in stack priority is the lowest of all the operators. So we can simply push this minus over opening bracket, increment the top pointer and push minus. Right? Now proceed reading. you read an operand, so you just print it here, okay, and proceed reading. It is opening closing bracket. So here when you read a closing bracket, then you have to pop items from the stack till you read an opening bracket from the stack. So here you're going to pop out this minus and do what with that, and just bring it to the resultant expression. And you cannot simply stop there, and you have to continue popping out till you read opening bracket. So you're going to pop the next item. This will also get popped from the stack. So this is minus and this is opening bracket. So you just pop opening bracket and simply drop it. Opening brackets are going to be dropped. So you simply drop the opening bracket. And closing brackets, how we are going to handle closing bracket? Whenever you read a closing bracket, then just pop all items from the stack till you read a opening bracket. So we are not going to take opening bracket or closing bracket into the resultant expression, right? So we are going to simply eliminate the opening or closing brackets or any kind of brackets here in the resultant expression. That is what is actually needed in Postfix expression also, right? So we remove. So how the stack will look like now? The stack will have, now the stack, I am just redrawing the stack here. Now the contents of the stack are this dollar, star and this exponent symbol. And you continue reading here, it is plus. So what will you do when you encounter a plus? It's an operand, it's an operator. And what are we supposed to do with an operator? When we read an operator, what we are supposed to do? We have to check the priorities. Priorities of what? Priorities of the operator that now you have read, and the priority of the operator that is there in the top of the stack. So priority of the operator on the top of the stack is higher than the priority of the operator now that is trying to get into the stack. So in that case, what are we supposed to do? We have to pop out elements from the stack till we find an element on the top of the stack whose priority is lesser than the priority of the operator that is trying to get into the stack. I hope you follow me. Do you?
Yes, ma'am.
Okay.
Yes, ma'am.
Right. Now plus is trying to get inside the stack, whereas we have this cap symbol on the top. Okay, you have to read or pop out elements out of the stack now. So you pop this cap symbol, and all the pop symbol has to be stored here in the resultant expression. So I pop out this cap and write it down in the resultant file and proceed with the next. So what is next there in the top? It is star. Now you compare plus and star, and still the priority of the element that is on the top of the stack is higher. So I cannot push this plus over star, not possible. So pop star also. Okay, pop star and do what? Print it here. And now what you have? You have dollar and plus. Whereas plus, the priority of plus is 1 and priority of dollar is minus 1. Now you can very well push this inside the stack. So here the content of the stack will now be dollar and plus. This will be the top. Clear? Proceed reading. X is an operand. Operand has to be simply printed. Proceed reading next. Next is what? An operator, that is slash. So you have plus on the top, and now you have slash to be pushed inside. You can always push because the plus, priority of the plus is lesser than the priority of the element at the top of the stack. So I'm going to push this plus, incrementing and pushing this slash over plus. Now Chichu.
Andu paduvadhu
Irada, irada.
ஒரு 2 minutes break எடுத்து அவன்கிட்ட கொஞ்ச நேரம் பேசணும் நடத்திட்டு டவுட் இருக்கா எதுவுமே கேட்க மாட்டாங்க வந்து அதை பேசிடுவாங்க
என் மைக் அண்ணன் கூடி போயிரு
ப்ளீஸ்
இரு நிமிஷம் முடிச்சுட்டு
சரி நான் இங்கிலீஷ் படிச்சுட்டேன்
Now what do you have? You have slash and proceed reading the next one. So when you proceed reading the next character, it is opening bracket. It's an opening bracket here. For opening bracket, I said you're going to simply push that on the top of the stack because its priority is going to be higher when it's trying to get inside the stack. So we're going to simply push that inside the stack. So you increment and push. Okay. And now proceed reading. It's an operand. So you're going to simply print it and continue reading here. It's an operator. So plus is an operator and now you have an operator whose priority is least of all the operators what we have in the expression. So you can very well push this inside the stack. You're going to push this plus inside the stack and continue reading here. To continue reading, you read next character, that is an operand. So simply have this here in the expression. Continue reading. You read what? A closing bracket. So when you read a closing bracket, what we have seen, you have to just simply pop out elements till you read an opening bracket from the stack. So you're going to pop out what? You're going to pop out this plus and opening bracket. So plus will be taken here to the resultant expression, opening bracket will be dropped. Okay. Now what do you have in the stack? You have only, now the stack has got dollar, plus and slash in it. These are the contents of the stack now. Okay. You have the top pointer here. And continue reading. So when you continue reading, you just read a delimiter. So when you read a delimiter which marks the end of the expression, then all that you have to do is simply go check whether the stack is empty. If the stack is empty, you're going to stop. If the stack is not empty, then you'll try to pop out all elements from the stack. So here the items from the stack that we pop out are slash and plus. So you just have it here. And you'll also pop out dollar, and dollar is the delimiter here. Right? So now this is the expression this is the expression what you have as the resultant expression. You can try converting this manually and check whether the answer what we got here is right or not. This algorithm is called a shunting yard algorithm. The algorithm what I explained you now is called as shunting yard algorithm for converting infix expression into postfix. Right? So here this diagram shows how actually the algorithm works. The same thing what I explained you in the previous slide has been explained here diagrammatically. Why the name shunting yard is like, you would have just seen the railway shunts, how actually they redirect the trains on the crossings. அந்த மாதிரி இருக்கிறதுனால ஒரு ஸ்ட்ரக்சர் இருக்கிறதுனால this algorithm is named as shunting yard algorithm. So you could see here this is an operator stack, right? And when you read an operand, it will just go to output. It is shown here in B. You can just look. Is the screen visible? And is it clear?
It's not visible.
Okay. Now is the diagram clear because I have just zoomed it up? Maybe I'll read it. So first we read character A from the input, and since this is an operand, it is going to the output directly. So it has come here. In step 2, we read the next character from the input. Next character what we read is an operator, so that gets inside the stack. So you could see in diagram C, there inside the stack you have plus already. Right? and the next character what you read is B, so it gets into, so next character what I read is B, so that gets into output. And now next is star. Star is an operator, so this star's priority is higher than this plus, so we can push that star inside this stack. Okay, so it is getting inside the stack. And the next character what you read is an operand, so it goes to the output, right? So in next character what you read is an operand C, so it is there in the output here. Okay, and next what you read is minus, so minus will try to get into the stack, but here the top of the stack has the operator whose priority is higher than the one that is trying to get into the stack, so you have to pop out star first, so it is getting popped out here. Look at this diagram. So it is star is getting popped out, and now we again check the priority of the next top operator. Next top operator is plus, so again this is equal, so only if it is lesser we are going to put it on the stack, or otherwise if it is greater or equal we keep popping. So this plus will also get popped, so you have plus and star here in the resultant expression. So star getting popped out first, then you have star next to C, and then plus. Now the next operator, and also you push this minus after popping out these two, because the stack becomes empty. Okay, so you proceed with reading the next character. Next character what you read is an operand, so that goes to the resultant expression D here, and it is the end of the expression, and all that we need to do after we reach the end of the expression is to pop out the remaining items from the stack and get it here in the result. So you pop out this minus and put it in the result, you get the resultant expression as A, B, C star plus D minus. Whereas the expression infix that is given as A plus B star C minus D. So B star C has to be done first, so we have it here, and then plus and minus have same priority. From left to right we take the priority always, so plus has to be evaluated first, so we have plus next and then C. It's all done. The same algorithm or the method shown diagrammatically in a different way. So this algorithm is called a shunting out algorithm, and I'll explain you how this expression what we have converted into postfix can be evaluated with the help of the stack. I'll take another 10 minutes. 1 second. Email class okay, this diagram, is this table visible to you? Guys, can you see a table on the screen?
Yes, ma'am.
Okay, so this table actually shows you how the postfix expression is getting evaluated and how you get the results. I'll explain you now how this could be evaluated by the help of the stack. So normally, as I said in the previous session also, I think I have helped you understand how this evaluation will happen. So the system is going to scan the expression, and it stops scanning once it reads an operator and applies the operator on the immediate preceding two operands, and evaluate it, put the result back in the same place from where it read the operands and operator, and continue scanning the expression and this repeats till the end of the expression, and finally we get the answer in the as the result. Right. So here some examples are shown here in this table. So taking the first example, 311 plus. 311 plus is a postfix expression wherein the system will start scanning from here and reads, and it stops here when it reads an operator that is plus and applies this operator on the immediate preceding two operands, that is 3 and 11. So 3 plus 11, 14 you get here. And I will do the same for this lengthier expression. Coming here, the system will start reading from 9 and it stops when it reads plus. You could see here in the other side of the table, it has been highlighted with a different color. So 5 and 3 added together and the result is put back in the same place. Right? 5, 3 plus, you get 8. Okay? Is this clear? Now continue reading. It reads 2 and 4 and it stops reading here when it reaches this cap symbol. So 2 per 4 will be evaluated and the result will be put back. So 9, 8, 16, and it continues reading, that is minus will be read. So 8 minus 16 minus 8 will be put back as the result, and now you have plus, continue reading here, it is a plus, so it will just add 9 and minus 8 and you get the result minus 1. I hope this is clear. This evaluation pattern is clear. Now let's see how this is going to be done with the help of stack. So what the system does is, when to evaluate it, I said that it's going to read, right? So when it reads, and immediately when it reads an only two cases possible. One is reading an operand, and the other one is operator. And one more case is like delimiter. You should know where it stops, right? So what the system does internally is, when it reads an operand, it will push. When it reads an operator, it will pop and apply and push. These are 3 steps you have to remember. When on reading an operator, pop respective number of operands, apply the operator and push the result back. And if it is a delimiter, then you stop, and the bottom stack is going to have the result in it. I'll do this for this example. Let's take 9, 5, 3. We start reading. So we push 9. Okay. So because that is an operand, and 5 is an operand, will get pushed. 3 is an operand, that will also get pushed. No priority, nothing here. Okay. And next what you read is an operator, plus. So on reading plus, pop items 3 and 5. Plus is a binary operator, so we need to pop 2 items. So what you do, 5 plus 3 equal to 8. You popped item, applied operator, and what you have to do next, you have to put back the result. So here, maybe I'll draw the stack in sequence for better understanding. So you pushed 9, 5 and 3, and now you read plus. On reading plus, what you have done is, you have popped 3 and 5. Okay. Now what is the content of stack? It is 9, and apply the operator, put back the results. Okay. Now continue reading. So when you continue reading, you read 2. So push 2 and push 4. Now what you read? You read par symbol. Okay. So on reading par symbol, what you do is, you have to pop the topmost items, 4 and 2. Okay. So what I can do here, after popping, you are going to apply the operator, get the result, and push. Push where? To the operator stack. So you push 16 here. Okay. Continue reading. So now what you read? You read minus. So when you read minus, you have to pop out items 16 and 8. So here 8 minus 16. This is on reading minus. Okay. So you get what? Minus 8. Push that inside the stack. So you have 9 already there on the stack, and now you're going to push minus 8. So what's next? You read plus. On reading plus, you have to pop out 9 and minus 8. So on plus, you read 9. So here 9 and so plus minus 8. So what's the result? It is 1. So you have to push this. We have pushed minus 8, and now we are going to push 1. Push 1. Okay. Now you read the delimiter. So you stop. Stop on reading delimiter. Or you would have read dollar as we have attached dollar in the end. Stop. So you have the result in the bottom stack when you stop the execution. Now you could understand that with one single scan and not bothering about the priority of the operators, we could get the results correctly. No priority here of any of the operator has been considered. So it was just one single scan. Yes.
Ma'am, is that a hash or a dollar at the end, ma'am?
Dollar can see why I've chosen dollar here is like when we converted, we had this dollar as the delimiter. You can use any symbol because see here in the previous case when we converted, we had dollar in the bottom of the stack and that would mark the end of the postfix expression, right? In the end of the infix expression will be hash here. Because of this dollar here in the bottom of the stack, this dollar serves as the delimiter for the postfix expression. That you need not bother about that. You can have any symbol which is not an operator. That is what is important to understand here. It should not be an operator, or otherwise we will misunderstand and we try to apply operator on the operands. So if this happens to be one of the arithmetic operators, then we will go wrong here on reading that. So it should be some symbol which is not a symbol that is there in the operators list. That's it. You can have any symbol, no problem.
Why it is required to use a delimiter, ma'am,
when will you stop the program? When will you stop reading the input? You can't keep on reading the input, right? You'll not know the length of the expression. You don't know how many characters are there in the expression.